helps computers learn that the cat and dog are kind of similar because their numbers look alike, but banana is different. And the computer uses this kind of vector to do smart stuff like find similar words or answer questions. And now, of course, this is a super simplified example, but imagine that this is a multidimensional system where you add more and more meanings, more and more concepts to describe words. For instance, that the cat is fully domestic, but the dog needs to go outside. And you have to, and then basically the numbers of the cats and the dog, of the cat and the dog, they change. But they're still in that same kind of very close nearby vicinity in this huge, massive network of meaning. So basically, to, computers don't really read the word cat or the word dog. They read vectors. They read a sequence of numbers that explain this word. This is why translation tools based not on library or dictionary, but on large language model are so good because they just the word cat has the same vector positioning in this massive network and matrix of meaning in every language. So the computer needs to just swap the language, but it will understand the meaning. But now, let's go to my favorite topic, natural language processing. This is the basis of most of the large language-related AI tools we see today. In some shape or form, whenever there is text, whenever there is language, there are elements of natural language processing. And I want to break it down in a simple way. Imagine you're talking to your phone and you say, "Hey Siri, what's the weather like today?" And Siri replies with, "It's sunny and 36 degrees Celsius." How did you know that you meant what you meant? And how did you know to give you the right answer? And that's natural language processing in action. So, natural language processing is a field of computer science that helps computers understand human language, like English, Spanish, or even emojis. And it is this is how apps like Google Translate know how to convert one language to another. ChatGPT can have a conversation with you. Spam filters in your email client know which emails are junk. And autocorrect and predictive text help you type faster. But now, isn't this just programming? Sort of, but not really. Here's the challenge. Humans use slang, sarcasm, misspelling, and all kinds of weird rules that when we talk or when we write. For example, if you write "I'm dead" and a smiley emoji, you don't actually mean that you died, right? And basically, all those models need to understand context and slang. So NLP teaches computers to deal with all the chaos and still make sense of what you really mean. So in short, NLP means teaching computers to read, understand, and talk like humans. And it's like giving a computer the brain to have a conversation. But first, let's talk about what I circled in the timeline in the 1980s, the original rule-based natural language processing. And this is one of the oldest but still very useful approaches to teaching computers how to understand language. So what is rule-based natural language processing? This means basically hand coding a bunch of rules that tell the computer how to understand or respond to language. Think of it like making a big if-then cheat sheet. So if you say hello, then the model should respond with hi. If a sentence ends with question mark, that means it's probably a question. And if the word dog appears, it might be about animals. Humans used to write these rules manually based on how language works. This is why we had, it was quite a trendy discipline for many years, computer linguistics, because this is exactly what computer linguists were doing, writing this kind of language rules in a computer programmable way. Simple example. Let's say we're making a chatbot for a pizza place. And we might write a rule like if sentence contains order and pizza, then respond with sure, what kind of pizza would you like? This is a structured logic. It's like coding languages into yes and no decisions. And as you can imagine, it can work quite well, but it can also miss a lot of different approaches. So this is a comparison between the rule-based, the old NLP, and the modern, we can call it modern NLP, that is based on machine learning, large language models, and neural network analysis, the type of the type of NLP that we see in ChatGPT. So rule-based NLP is built by human written rules, while modern NLP is built by machine learning from vast amounts of text. Rule-based NLP does not learn from data, while modern natural language processing systems like ChatGPT do learn from data. Rule-based NLP is very good for specific controlled tasks, while modern NLP is good for conversations, even creativity, and is quite good in handling nuance. Rule-based NLP, would it handle slang and sarcasm? Not really, unless it has been purposefully built for this. Modern NLP like ChatGPT is pretty good in handling slang and sarcasm. But now, the very important final point. Can you, as a user, understand how it works? Rule-based NLP is totally transparent. You can see the rules. You can see that if something does not work, you can identify which rule is the reason this thing did not work. Modern NLP systems are complex and hard to explain at times, and it's a black box. You don't really know exactly what drives a certain outcome. So the pros of rule-based NLP, it's transparent. It works well with limited data. You don't need tons of training examples. And it's very useful and precise for specific tasks. So this is why it is still in use. It's used in things like legal documentation, medical information, any area that has very strict wording. But then, of course, there are cons to rule-based NLP. This is why there are many systems are moving away from rule-based and into machine learning. Because it's brittle. One small change in phrasing can break everything. For instance, if in the example of the pizza ordering chatbot, if you have programmed it with a rule that says, if you hear the word order and pizza, this means that someone needs to order a pizza. But if the client says, can I grab a pizza? That system might not trigger the rule for order pizza. And it's also hard to scale. You'd need tons of rules to handle all the ways people speak. So it's not practical. And then this is not real understanding. It doesn't learn the language. It just follows instructions. It is still used, however, as I said, in some chatbots for customer support, in many grammar checkers, and it's used in medical system where accuracy matters more than flexibility. And it also commonly used in voice menus. Let's say, press 1 for support. But now I'm going to Bob Dylan. Just give me a short second to have a sip of tea. So now imagine you are a large language model, and your job is to predict the next word or understand the meaning of a sentence. But how? Well, this is where transformers come in. And transformers models, it's very interesting because they bring in the concept of attention in training models to understand language. How many words do you need to pay attention to before the word you need to generate next? Let's look into this. Think of an LLM like a brain trained on tons of text, like books, website, lyrics, conversations. And the model is designed to learn how words flow together. So when it sees a part of a sentence like early one morning the sun was shining and I was laying, it can guess the next word might be in bed because it's seen that pattern or something similar many times before in training. What is important is that models treat a sentence and a text as a sequence of words. What the model would need to understand are there any words in that sequence that are repeated? Let's say here we have 3 times was and 2 times if. So we can convert this sentence into a graph, adding the probabilities of each intersection. So early one morning the sun was, it can go shining, but it can go laying in bed or still red. Or her hair was shining, or her hair was laying in bed. So these are the different paths this sentence could take when we look at the repetitive words. So starting from various nodes, we can write like Bob Dylan. The sun was still red, her hair was shining, the sun was laying in bed, but not all paths make sense. So this is where we need to understand and we need to train the model how to choose the best path. How to do it? You need more data. You can't train a large language model on one verse of a Bob Dylan song. You need everything Bob Dylan has ever written. Then you need to extend each word memory because each word is not just affected by the previous word. It might be affected by the 2 previous or even more. For instance, research has shown that to capture rhyme, we need to go back 13 words on average. I'm going off camera for a second.
Kalau ada yang ingin bertanya silakan ya, bisa angkat tangan, bisa ditaruh di chat juga.
Okay, I am coming back. So within the training of large language models, these are the decisions that are taken to come up with the approximation function. This is how it looks, and to generate the so-called neural network. And basically, the generic principle is that phrases and words are being paired, and this is how you model the desired behavior. Let's look into trying to predict the next word. So we want to just predict the last word, in this case, red. And the neural network is the black box. This is the input. What happens in the black box? A neural network like that would be really hard to handle and use, right? Because you expect every single word to be able to predict that last one. So do you need all the words to predict that last one? Or do you pay attention to a specific subset? This is where transformer models come in. They help the model identify which are the words that you need to pay attention to. So it turns out that to guess the word red, you need to know the word that it has to rhyme with and the 3 words before it. So we will craft our neural network that incorporates the attention layer. And this is how a neural network in reality would look like. It's very simplified terms, but basically we have the attention layer, and the attention layer helps the model identify which are the words it needs to pay attention to, and then it goes into the next word prediction based on its corpus of training data, because it already knows that Bob Dylan loves to write songs about his girlfriends. So this is how he would know that this is a song about a woman. There is a bed there, and her hair was still red. So why all of this matters to me and people in my industry, and why it should matter also to you if you are interested in pursuing a career in media intelligence. Probably this would repeat many things that Professor Ngoroho has already said. But of course we need. I just wanted to make sure that we're on the same page. So this industry, media intelligence, communications measurement and evaluation, social media listening, these are all different names of that industry. What we do is we are working with media content, mostly text, but of course also audio and visual. Our industry includes multiple different types of companies. Companies doing clippings or monitoring, evaluation and insights focused companies, social media listening platforms, in-house media evaluation and analytics teams, PR agencies, a lot of different types of stakeholders. But really, what um, what is the lowest common denominator? We all work with data. We all work with data, and most of this data is textual data. Um, and basically, as an industry, this industry exists since the mid 19th century in some of the oldest types of companies in this industry, like the press clippings. And it has developed over the 20th century to detailed metrics and evaluation, and this type of impact measurement that we're seeing as the standard, as the best practice in the industry nowadays. And algorithms have been part of our reality for a long time. Several phenomena in the past decade have driven the adoption of algorithms in the media intelligence industry in its broadest sense. Number one has been the increased volumes of content coming from online news media and from social media. The other has been clients' increasing demand for faster turnaround and, of course, lower cost. And this is, of course, driven by a real business need to predict crises before they happen or to prepare to mitigate negative effects of brand reputation. So, with these two factors alone, increasing amount of content and client demands for faster turnaround, we can't, as an industry, stay in the 19th century or the 20th century. We have to make sure that we optimize, automate as much as possible. AI-based models are already in use for aspects of PR measurement, broader media intelligence, and risk monitoring. And this applies for everyone, PR agencies, in-house teams, and specialized measurement evaluation agencies like the one I work for. So different AI models are used to scale up, to improve methods, and or even to build up new services or products. And broadly speaking, there are two options for embedding artificial intelligence in a media intelligence practice. One is to purchase off-the-shelf solutions and that use third-party taxonomies, and others is to invest in an in-house machine learning and data science capabilities and create your custom models. Both of those options are valid and used in the industry, and we can perhaps talk about it later on, why one would be better than the other. So, what types of automation do we already have in place, like way before ChatGPT? So, automation has been in place for a long time, and it could be automation based on, let's say, libraries or rule-based. Of course, also kind of classic machine learning, training corpuses of data. And the types of problems that those models are already solving are things like content clustering, which is grouping similar content together, topic classifying, um, analysis of tonality or sentiment, named entity recognition or entity extraction and classification. This means in a certain piece of text, is there a brand or a company mention? Is there a person mention? Auto summarization of news, stylometric analysis, so the style of a language used. And specifically, large language models like GPT are as well already used in the industry, in content summarization, in message pull-through analysis, and in key phrase extraction or other um, types of analysis necessary for answering client research questions. What happened with the launch of ChatGPT? Democratizing large language models and AI. Clients are becoming more demanding because they are playing with ChatGPT as well, and there is a perception that everything can be faster and at a lower cost. And some clients would go the do-it-yourself route, which is again perfectly fine. It's part of what they have to decide for themselves. But it means that there is a lot of things going on in the industry where we have to catch up with clients' own technology adoption. So how AI helps in media intelligence in a very simple terms. It helps us get data and content, it helps us process data and content, and it helps us present this data. So AI-based tools in the getting phase can help us scrape web content, power the type of searching that we need to create a sample, group similar content together, extract different types of data. Then in the processing stage, it can help us really with a lot of elements, summarizing, classifying, and so on, integrating different data sets. And in presentation, of course, it can also helping us visualize the data, writing up explainers, or even produce insights based on data and content. From my research, both from what we are doing in my company, but also I've been talking to um, many peers in the industry. These are the main tasks in media intelligence and content analysis where AI models help. Prioritization. What do we mean here? What type of content matters most? Why? How can we identify from, let's say, 1,000 of social media posts around our imaginary pizza restaurant, which are the most important? And we'll have to and models can help us find those, not just because of, let's say, number of retweets or likes, but let's say the meaning. Oh, maybe this is a critical one, this is a criticism we need to respond to before it gets viral. Summarization. With so much data, with so much content, we need to be able to quickly understand the gist of something, the main story, and this really really helps us. Extraction of information, large corpuses of information, large corpuses of text, but extracting specific elements that are of interest. And classification is part of the content analysis that has historically been one of the most expensive parts. Now, there's so much optimization, be it with rule-based models, with classic machine learning models, or with new large language models that help us classify content by sentiment, by topic of conversation, by different aspects we want to break down what we are analyzing. And finally, meaning and insights generation. Large language models do show very good results already in providing meaning and insights generation. On the market already, there are many, many different types of AI tools and offerings. This little word cloud is something I generated after analyzing over 60 press releases and product launches in PR measurement, media monitoring, media intelligence related fields. Our industry has includes also PR technology providers, so platforms that, for instance, could not just analyze social media coverage, or traditional news media, but could also be used to write up and send out, distribute a press release. So the catchphrase is coming with big promises are assistant, insights, and predictive. And these are the four main areas that I identified as based on this analysis: writing assistance, automated insights, chat interface for search, and then, of course, the huge area of backend features and additions. How many of you have ever seen a social media listening platform